Hello friends, so how are you? So today we are solving this problem, path with maximum probability. So in this question, what is happening? We are given the one 2D array of edges where the edges are given of a graph, and we are also given the success probability. So whatever edge is there is a corresponding probability to reach from A to B, like this. In this case, A and B is the A's, then if it is ith location there is a AB, then at same ith location in succProb array there is a probability. Okay, so what we have to do is we are given the source and destination, start and end basically. So we have to find a path which is having the highest probability. Okay, so you can understand here. See, here we are given this graph, and these the values here given are like from 0 to 1. If you want to reach, the probability would be 0.5. 1 to 2, the probability would be again 0.5. 0 to 2, it is 0.2. Now here you can see start is 0 and end is 2. Okay, so what would be the maximum probability here to reach 0 to 2? So you can see here, if we go directly from 0 to 2, what will happen? If we are going directly 0 to 2, it would be 0.2, right? But if we choose this way, that 0 to 1 and then 1 to 2, this is also a path, right? So how much it would be? It would be 0.5 into 0.5. As you know that in case of in case of probability, we do the multiplication, right? This is not the distance, but this is the probability. That is why we are multiplying it. So it would be become 0.25, right? So in this path we are getting 0.25, and in this path we were getting 2.2. So 0.25 is greater, right? So we will return 0.25 to reach from 0 to 2. So you can say 0.2500 is the answer here. So this is what we have to do. Now we will explain what would be my approach here. Similarly, we can see other examples as well, right? So in this case, if we want to go 0 to 2, if we choose this path, it is 0.5 into 0.5, it is 0.25, right? And if we choose directly 0 to 2, it is 0.3. So this time it would be 0.3 answer. Okay, similarly we have another example. So there is one more scenario. Let's say this is our graph, and start is 0 and target means the destination is 2, right? So in this case you can see we have a path from 0 to 1, but there is no path at all from 0 to 2, neither from 0 to 1 and 1 to 2, neither directly. So in this case what will happen? There is no possibility to reach at all, so it would be 0.000. okay, so this is the way what we have to do. Let me explain my approach here. So here you can see this is the edge, right? So if we go to 0 to 1, the probability is 0.5, right? So see here, 0 to 1 is this edge, so we can write down the probability here, right? Now come to here. If there is 1 to 2, the probability is 0.5. So 1 to 2, we will write down it 0.5. Now we are at here, 0 to 2, it is 0.2. So 0 to 2, we will write down it 0.2. Right? So basically what I mean to say is, in step 1, first of all we have to make a adjacency list of graph. And what type of adjacency would be it? It would be the adjacency which will store the information about the any index to age, to what index the age is there, and its corresponding probability. So how it would look? Let's take an example. So this would be an array list of the array of the array lists. Okay, so it would be something like 0, 1 and 2, right? We have 3 ages. So this would be our array of the array list, okay, of size n, and this would be having these corresponding value. So see here, from 0 there is an age to 1, right? So there is an age to 1, and what is the weight? Weight is 0.5. So we will write 0.5. Okay, 1 and 0.5. So this is one thing. Now what all connected to 0? So 0 to 2. So 0 to 2 we have a connection, and it is 0.2. right? So we will write 2 and the probability is 0.2 here. Okay, 2 and 0.2. So this would be the zeros connection. Now come to ones connection. So see here, 1 is connected to 2, right? And what is the weight? 1 is connected to 2 here, and the weight is the 0.5, right? So we will write down here 2 and the probability equal to 0.5. Now come to the last guy. This is 2. So with whom 2 is connected? So one more thing is, see here, 0 is connected to 1 and 0.5. Now because 0 is connected to 1, then 1 is also connected to 0, because this is a two-way or bidirectional graph, right? So we will add this guy 1 and 0.5 with the 0 as well, right? So we will write here 0 and 0.5, right? Because this is a bidirectional graph. Similarly, we are connecting here 2 is connected to 0.2, right? That means 1 is also connected with the 0.2 probability. You can see here as well. Okay, so 0 is connected to 0.2, then 2 is connected to 0 with the probability 0.2. So we will write down this as well. Okay, now we are coming at 1. So 2 is connected to 0.5, 1 is connected to 2 with 0.5 probability. So we will add this guy as well here. So 2 is connected to 1 as well, because 1 is connected to 2. So with that probability, right? So this is the one value. So now we are done for all of them. Okay, so this would be our array of size n and of type array list. Okay, you can see here, this is an array of like this. So first of all, we have to build this thing. Okay, this would be our array. Now one more thing is, you can see here, this is in first value is the integer type and second is double. So we just cannot store in a single int array, right? So we can make a class called node. Okay, we can make a class node, and this node would be having the integer city and the probability, double probability. Okay, so we can say integer city and double probability. Okay, we can call it like this. So we can store the node of this graph. Okay, so you can say here that this is an array of array list, where array list is storing these node objects. These are the node object, 1 and 0.5, 2 and 2. These are the node objects. So we will, in step 1, we will complete this adjacency list, and after completion of this adjacency list, we will use the Dijkstra algorithm for the probability. Okay, so guys, in this step 2, what we are gonna do is, we will create the Dijkstra algorithm with the maximum heap. Okay, so maximum heap is like in usual Dijkstra we find the shortest path, but here we are finding the maximum probability. So for that reason, we need the max heap, means the highest value should be on the top of it. So basically I will write the priority queue. Okay, this priority queue PQ would be stored the value of this node, right? That node we just created, which is having the city ID and the weight. Okay, so we will create a priority queue of nodes and keep on putting the values into that. So let's try run of that as well. So see here, as 0 is our source and 2 is our destination, right? So I have created one double type of double array. Okay, double type of array, and in this double, what I have done is I have put all others as 0 probability and initialized with the SRC. So 0 with 1.0, because a city from itself is always 1, right? Its probability, because that is already the city itself. So I have initialized it with the 1.0. Okay, now I have to start with the priority queue. Okay, my priority queue would be storing the value just like this. Okay, these node type. So let's say this is our priority queue PQ. I'm creating this priority queue PQ. So initially what we will post this guy. So its index is 0 and its probability 1.0. So initially our priority queue would be having a tuple of 0 and its probability as 1.0. Okay, so see here, so we will pop out this first. Okay, this is the only element. So while PQ is not null, we will pop it out, and then we will check to the adjacency of this 0, right? So its weight is, its probability is currently, it is 1, right? It is 1.0. Okay, now we will look for the its corresponding adjacency. So see here, this is the 0, right? So it is connected to 1, it is connected to 2. So let's take first this guy 1. Okay, so what is the probability of 1 in this array? It is 0, right? So if we write dist of dist of 1, which is 0, and basically it is less than the this thing. So as you can understand, this is the way. Okay, so initially we started from here, right? So we can call it like we have just post into the priority queue. First of all, we post this 0 and its corresponding probability, right? 1.0. We post the source value. Now we will pop out it from the priority queue, right? And for this node, we will traverse through the adjacency list of it, right? Like this node and this node, these are the nodes which are connected to this guy. Then this, if we call this probability B, so what we will do is basically we will check here that if probability of B means like this node, for example, we are going ahead, let's say we took out this, then we will go to adjacency of 0, right? So ADJ of 0. So in ADJ of 0, because this node is 0, right? So we will go to this node here. This is the list of 0. Now here we will pick. So first of all, we have 1, right? So we will look this guy. So what is the probability at 1? The probability at 1 is 0, right? So it is 0 here. Okay, here is the probability of all of them, right? So this is the 0, which is basically less than the probability of this guy. It was 1.0 so far. So 1.0 plus whatever the distance, so 0 to 1, this is 0.5 probability, right? So we are not making plus, it should be multiply, right? Because this is a probability. So we will write 0.5, right? So now what is happening? It would be 1 into 0.5, it would be 0.5, right? So this would be basically 0.5. Now what will happen? 0.5 is basically greater than 0, right? See here, in that case what we will do, probability V will become this guy. So we will replace here at 1.5, right? At the node 1 we will make it 0.5, right? Because we found this. Then we will go to this guy, this is 2, right? So what is the probability of it? So this would be, initially it is 0, right? 0.0. Then we will put the values here. So the probability of this guy is 1.0, which is already written. And what is the probability? It is 0.2. So if we multiply 1.0 with 0.2, it will come 0.2 only, right? So we will replace here 0.2. Okay, now we are done with this guy. Now our thing, right? So we are done with this. So this 0 has whatever node, these are done. Now similarly, this functionality, we are pushing those values 0.5 and 2, be pushing to the priority queue, right? And so in the priority queue we will keep on popping out and keep on updating just the way which we did for the first node, this guy 0. So we will write the code, this will make a better sense, but this would be the same concept would be repeated at the location 1 and the 2 city, right? So in this way we can finally have all the distance would be there in this array, right? Or distance of probability in this case. So in this probability, finally we would have all the highest probability in this case, and then we will return the value which is residing at destination, which would be our final answer. So in this case it would be basically 0.25, right? When we further dry run of it, it will replace here. So let me show you code quickly for this. See here, I just created a class item which has int city and double its probability, right? Because we have the heterogeneous data type here, so we cannot accommodate in an array, right? So this is the way I just created this class. Now here I'm creating this thing. This is my main method. So this is my adjacency that I have to fill. So let me show you where I'm doing this. So see here, what we are doing here is I just created this adjacency list, the class variable which I created, and I'm filling with the dummy array list initially. And see here, I'm going through this adds array. I'm adding this adds 0. So if somebody which is connecting with the node, it will also connect it with the other node, because it is a two-way, right? So that is why I'm adding this here, I0 and I1 and the corresponding probability, and also adding this to the I1, right, for the I0 and corresponding success probability, because this is a undirected graph. So if A is A to B, then B also connected to A. So for that reason I'm adding these two. Now finally I am calling the Dijkstra algorithm here after constructing of this adjacency list. See, here is my Dijkstra algorithm. So see here, this is my double type of probability array of size n. Initially I am filling everyone 0, and for the source I am putting 1.0, because source from source to source probability is always 1. Now I am creating this priority queue of type item. Item is the class which I just created, city and probability. Okay, so this probability I am doing the probability in such a way that it behave like a max heap. That is why I am doing this double dot compare on b dot probability and a dot probability, right? So top of it, it would be having the maximum probability guy. Now initially I am pushing the source and its probability, which is 1.0. Now see here what I am doing. Till the time our priority queue is not empty, we are popping out the things. This is the city and this is its probability. Now I am traversing through the adjacency list of this guy which we just popped it out from the priority queue. Now see here, this is the I am taking the item as neighbor. So this would be the city index and this would be its probability. Okay, now we are checking whether in the probability array, if the this city's probability is less than the probability of this guy which we just popped out into this guy V, right? So the multiplication of both of them, probability into P. P is the probability of which we just popped out, and this probability is the probability which was already residing in this our probability array. Okay, so if multiplication of these both, because this is a probability, so it is not sum, it should be multiplication. If it is less, then we are updating it, and then we are adding into the priority queue with this city index and its probability, because there could be the further smaller values, right? Just like we did it, we left it till 0.2 and added it into priority queue for the further steps. So similar way we are doing it here, and then finally I am returning the probability for destination, because this probability array has the best probability for every other cities, but we are interested for the destination. So I am returning this. So let me execute this code. Yeah, it is working fine. Let me submit it. Yeah, it is accepted. So thank you for watching this video. If you guys have any concern, please make a comment over there. Thank you.